Standard normal distribution is a normal probability distribution with the mean mu equal to 0 and the standard deviation sigma equal to 1. The total area under its density curve is equal to 1. And again, that's true for any continuous probability distribution. So here's a picture of our standard normal distribution. And this is really just a special case of a normal distribution. It's just that it has a specific mean, which is 0, and a specific standard deviation, which is 1. And it actually corresponds to the z-scores that we talked about in Chapter 3. Because the values of the random variable here correspond to z-scores, we use the variable z instead of x when we're talking about the standard normal distribution. Here's an example with the standard normal distribution. For a standard normal distribution, what does the area under the curve for z greater than or equal to 1.5 represent? What does the remaining area under the curve represent? Here's our picture again. And if we put in the value of 1.5, and since we're talking about the area under the curve for z greater than or equal to 1.5, we're going to shade from here over to the right. And you're going to be shading in the same direction as your inequality points. So this area that we've got shaded represents 1, the probability that the z-score for a randomly selected member of the population is at least 1.5, or another way to think of it is it's the proportion of the population with z-scores of at least 1.5. The remaining area under the curve, in other words, the part over here that's not shaded, would represent the probability of the complement of the event z is greater than or equal to 1.5. So this part that's shaded is the probability for z greater than or equal to 1.5. The part that's not shaded would represent the probability of z less than 1.5. And remember we said the total area under the curve had to equal 1. So if we knew the area of the shaded region, then we could find the area of the unshaded region by subtracting from 1. Now we're going to talk about finding areas with normal distributions. This is the same thing as finding probabilities with a normal distribution. There are two methods for finding the area under a normal curve or for finding a probability for a normal distribution. These are using tables and using technology. In this class, we're not going to use tables. We are going to use technology. You have two choices for the technology. You can either use your graphing calculator, your TI 83 or 84, or you can use StatCrunch. In the last couple of years, most of my students have gone to using just StatCrunch for this. So we're going to spend most of the time looking at how to do this with StatCrunch. I'll show you briefly where the function is on your TI 83 or 84. And then if you want more information, please feel free to ask me. If you're trying to use your graphing calculator, what you'll use is the normalcdf function. To find it, press second and the VARS key to get to the distribution menu. The normalcdf function is the second one in the list. Be sure to use normalcdf and not normalpdf. This function asks for a lower bound for either z or x, an upper bound, the mean, and the standard deviation. Depending on how old your calculator is, you'll either see normalcdf come up on your screen, or you'll get this screen. In either case, fill in the lower bound, the upper bound, the mean, and the standard deviation. You'll end up with something like this on your screen. Press enter to get the calculated area or probability. Now let's look at how to use the StatCrunch normal calculator. First of all, to find the normal calculator in StatCrunch, just open StatCrunch and go to a data editor screen. It can be a blank one or it can have data in it, it doesn't matter. Then go to Stat, Calculators, and Normal. You should see a window like this come up. This has a place to fill in the mean and the standard deviation. You'll need to fill in the appropriate inequality symbol in here. You have two choices, either a less than or equal to or a greater than or equal to. And you'll be able to fill in either the value to the right of that or a probability or area way off to the right. When you click on Compute, then the picture will change to reflect what you put in. Notice how this is shaded a different way than this is. This gives us the picture of x is less than or equal to 1.17. It also filled in a probability or an area. This is the probability that x is less than 1.17. It's also the area of this shaded region. Let's go through that whole example. If we want to find the area under the standard normal curve to the left of z equals 1.17, the first thing that you need to do with these is go ahead and sketch the picture for yourself. That way when you get the picture in StatCrunch, you can see whether it matches and whether you have put in the right information or not. So we're just sketching a normal distribution. Be sure and mark the mean in the middle of it. You don't necessarily have to mark these other tick marks for the standard deviations, but make sure and put the mean in the middle. If we're talking about a standard normal curve, the mean is always 0. And then you also need to mark the z value that you're looking at. In this case, it was 1.17. I marked this on this graph, and then it wanted the area to the left of that, so I'm shading all the way from there all the way to the left. This is what my picture looks like. And when I go to the StatCrunch normal calculator, I'm going to click on standard at the top. I'm going to put in 0 for the mean and 1 for the standard deviation. Since this is the standard normal curve, those are always the values for the standard normal distribution. I'm going to put in the inequality less than or equal to. It points to the left, and they were asking for the area to the left of 1.17. That is why I want my inequality to point to the left. Then I'm going to put in 1.17 for the z value, and then I'm going to click on compute. When my picture comes up, it should match the picture that I had sketched. What it's doing here is shading to the left of 1.17, and it's giving me what that area value is. So the area that's shaded is approximately 0.8790. That would also be the probability that z is less than 1.17. Let's do another example. This time we're trying to find the area under the standard normal curve to the right of z equals 1.17. We're going to do our sketch again. This time we've got the same picture and we've got the 1.17 here again, but this time we're going to the right, so we're shading to the right. That means when we put this into StatCrunch, we want to change our inequality so that it points to the right so that it will match our picture. Here's what this should come out looking like in StatCrunch. Notice we have the inequality changed so it points to the right. We have our z value in there. I already clicked on compute for this, so it's already giving us the area that's in this shaded region. That area is going to be 0.1210 if we round it to 4 decimal places. Now we're going to find the area under a standard normal curve between two different values. This time we're looking for the area between z equals 0.13 and 1.35. We're going to sketch our picture again. This time we want to mark both of the z values on our horizontal axis. Here's our 0.13, here's our 1.35, and we shade in between those two because it wants to know the area between those two values. In StatCrunch, if we have two values like this, then we need to use the between window instead of the standard window. So click on between at the top of the normal calculator window. Put in the two values for z, so put in the 0.13 and the 1.35. It's important when you do this that the smaller one of these is on the left. They need to match what it's going to look like in the picture up here. If the 0.13 was to the left here, then it needs to be in the left box over here. I have those two values, and then if I click on compute, it will give me this picture. It matches the picture I had sketched, and this is my area or my probability.